Hello everyone, I'm Fernando, and I'm excited to announce that I'll be speaking at the upcoming online API conference organized by Manning this August. I'm going to be covering how to use Redis together with your microservices to create reactive architecture. I can't wait to be there. See you soon. Hi everyone, I'm Fernando, and today we're going to be talking about fun with Redis, essentially how to use Redis to create a reactive architecture with your microservices. Like I said, I'm Fernando. I've been working with scalable architectures and the web platforms in general for the past 18 plus years. I've even written a few books about microservices and scalable architectures as well. You can look them up on Amazon. And I'm the author of the upcoming Manning book, God Well, with others, that you can check out if you're a new developer or someone thinking about getting started in the industry. So what are we going to talk about today? So essentially, I want to sell you on the idea of reactive architectures and what they are, why they're such a great approach, inter-service communication, and how you can use Redis to create them. So let's get started. So what is a reactive architecture? Let's start with the basics. A reactive architecture is one that values the client's time overall. And by client, I mean any piece of software that sends a request to a resource and it needs a response, essentially. So on a normal microservice-based architecture, usually through HTTP, the client uh, would need to stay locked, essentially, waiting, for that response for whatever request it sends. So it can either just wait there until it gets the response, or times out given certain time, or keeps actively polling the resource to see if it's ready and if it's ready to be retrieved. However, on a reactive setup, the client can send the request and just keep doing something else. The server doesn't need to know about it. From the server's perspective, nothing changed. The request needs the same amount of time to be fulfilled. However, from the client side, time is optimized. Why? Because following this pizza example, the total time or the overall time to get the pizza that didn't change. It's still the same. However, in the meantime, after we requested the pizza, we can just go and set the table, get some drinks, call some friends to I don't know, check up on them, and then get the pizza. So we did a lot more between 2 and 4 that we were able to do before giving our um, basic approach at client-side communication, client-server communication. So how does this translate into a more architectural point of view? And essentially, it translates to this. So to having a producer, which is essentially a component that sends an event somewhere, and that can, however, be used however other sides of this architecture want to. The event itself, or a message essentially, that contains all the relevant information that the other side needs. The message bus, that is the medium through which all these events travel from producer to consumer, and then the consumer itself, which is the bit of logic essentially that reacts to the message. There is no direct communication between microservices here, as you can see. Um, and a very important thing as well is that not every consumer needs to react to every event, to every message. This is key to optimize as well the communication, especially when we have a huge number of consumers. Um, they can be spread out through different type of messages, and so we don't want to notify everyone every single time. So this is essentially a way to use the observer pattern on an architectural level. Now that we know what a reactive architecture is, why choose it? Why go for it? like I said, it helps optimize client time. It helps the client be request something and be free to do other things at the same time. So while it doesn't really reduce time overall for a request, for a particular request, that's on the server side, that's on the service side, sorry. uh, the the client itself is able to do something else, to work on something else in the meantime. That also, from a UI perspective, for instance, it makes it fluid. It makes it easier to notify the user what's happening, and instead of being locked on waiting something to happen. It also simplifies the multi-service requests, essentially complex use cases where a single request from a client requires multiple microservices to interact with each other. Um, on a normal scenario, you will have either to write code on the client side to orchestrate how many and which microservices need to interact with each other, and or either that, or have that orchestration logic spread out through all the different microservices involved, each one knowing which one to call after each other. So this approach simplifies that intercommunication, because each service becomes essentially a consumer for the client's request, but also a producer for their own events that other microservices will pick up on and start interacting. It's also a lot easier to add new services. This is, again, thinking about that complex scenario with multiple microservices interacting with each other. If you had that orchestration logic written somewhere, adding a new microservice would mean adding code to that logic, extended it somehow. And however easy that might be, based on however you might have structured it, it's not going to be easier than just not changing any code, essentially. So on a reactive approach, you don't have to change code. Adding a new microservice on these type of scenarios, you would just create the microservice, encapsulate that logic inside a new service, and then have it subscribe to that type of event. Maybe one exists already existing, which will be the ideal case, or a new type of event, but that will be it. The other microservices would need to know which type of event to produce. That would be it. It's a minor change, a minor modification compared to any other approach. And finally, because of this, you see how we can decouple services from each other. So all the services don't need to know if there is anyone else around to be called, or if there is, where they are, or what they have to do with the data, or how they require the data. All they need to care about is the message bus. The rest is up to however you configure that interaction. So that's what makes a reactive architecture so special. Of course, was nothing's perfect. There is no single approach to all type of problems. So it also comes with a few cons, especially and mainly, it's definitely be hard to debug. Reactive architecture is asynchronous by nature, and data can flow in very different ways. So unless you add some metadata around the messages, the events, so that you can understand which microservice interacted with it, and how, and what they did to that data in between, the client and the request and the final response, then you can't really track everything that happens. That's one thing. And the other big thing is that it requires a change in mindset. For microservices, we're very used to client-server approaches such as REST that simplify a lot the communication paradigm between the starting point and the end point of that flow. Whatever happens on the server, that's fine, but the client is aware that it sends a request, and it'll just stay there waiting for a response. On this reactive paradigm, that changes. it's completely asynchronous. So both client and internal microservices, they need to understand that, and they need to know essentially that everything has to go through the message bus. Essentially, those are the two main changes that had to happen, and definitely, personally, I think they're worth the trouble. But that is something, of course, that you have to use and decide at your own discretion, depending on your particular use cases. So far, we've been talking about reactive architectures, and hopefully, I've been able to sell you on this. However, we need to now talk about Redis and to finalize the idea of how easy it is to create this, especially around Redis. So if you don't know already, Redis is a NoSQL database. That means that um, there's no enforced schema to the data you save on it. There are no fields or tables like you will find on a SQL-based database such as MySQL or Postgre or Oracle, anything like that. There's no concept of private key, foreign key, or any kind of relationship between records. Essentially, in Redis, you save data on using key value pairs. The key, which is a string, and that acts as the unique identifier for a record, and then the value, which is another basic type, such as a number, a string, or a list of other basic types, but that is about it. Um, the, the storage structure is very simple, very basic, but the main thing about Redis that it's an in-memory storage. That means it's built for performance. Writing and reading in-memory data, it's a lot faster than getting it from disk. Around, depending on the benchmark and everything, but it's around 10 to 20 times faster. So we're talking about considerably high speeds when you have use cases that require a lot of read and writes on data, such as, for instance, a typical use case for Redis, which is caching. So checking if the cache is there, checking, reading it, getting that information, and so on. It's might happen very often and needs to happen very fast. This is why Redis shines in such scenarios. However, as we're going to be seeing, there is a lot more to Redis than just reading and writing data on memory. So while key value pairs are essentially based, the basic core structure of Redis, we want to look a bit beyond that. And the two main features of Redis that I want to cover here that are key, in my opinion, to creating a reactive architecture are both PubSub and key space notifications. On one side, PubSub is out-of-the-box message queue that comes with Redis. You don't have to do anything. It's already installed by default, and it can be used simply by connecting using essentially a different method on the client to connect to it. But so it gives you immediate access to a producer consumer paradigm, essentially what we've been discussing so far about reactive architectures. And it doesn't, the other key here is it doesn't affect normal operations. That means if you're using Redis already for anything, cache or whatever you were using it, that's not going to change. It's not going to be affected by the PubSub use that you might give it. So that you have essentially, if you have Redis, you have that message bus that we saw before already there. And the other key thing here that I want to highlight is the key space notifications. That feature to me is another fantastic feature from Redis that simplifies even further the creation of a reactive architecture. So essentially, key space notifications are sort of like a PubSub, but with predefined events, right? So we talked about events before. We talked about how the producer can choose which events to send, which kind of messages to send, and on the other side, the consumers will pick it up if they wanted to, right? So here is Redis itself acting as a consumer, sending specific events around keys. So events such as delete, update, or expire. That means if we update a key, we can get notified. If we update a key means updating a data, a value on the storage. Deleting a key or creating a new key even means saving something new to Redis, and we get notified. Um, in particular, the one I'm going to be also covering is the expire event, which is my favorite event because it allows you to, it not only allows you, it completely simplifies uh, the creation of time-based events. So we're going to be covering that in a second. So, but before, and to highlight this, you can think of uh, microservices in a reactive architecture as independent building blocks or Lego bricks, if you will. And to put an example, a very silly and trivial example, look at the side box on your screen. So we have very simple save user function that will do two things. It will save the user to whatever storage we're using, right? And it'll notify not notify, sorry, it'll send a welcome email to that user, essentially, right? Welcome to our application or whatever. Um, the code is fine, it works, but there is a slight coupling here because our function that is in charge of saving the user into storage medium is also in charge of sending an email. And that's not something that we want. And even if we were to abstract that send email method into a more generic notify or welcome user, right? The save user function would still be in charge of orchestrating that logic. And here is, again, the word orchestration. I said it before, we don't want that in our code as much as we can because changes in that orchestration means changing in the code. If we can move away from that, it simplifies the logic a lot. So instead, think about splitting those two lines into different functions as smaller microservices, as smaller Lego bricks. On one side, you just have the save user, which saves the user, and that's it. That's its whole responsibility. And then you have the welcome user function that is in charge of sending an email, yes, but that's the only thing that it's doing. And through events automatically sent by Redis once the user is saved, you can connect these, or yeah, correct, connect these two functions, these two logic sections of your code. It happens, so the notification or the welcome email happens as a side effect of you saving a user, but you don't really have to worry about in the future changing the way you notify the user. So if instead of sending an email, you also want to, I don't know, send a WhatsApp message, all you have to do is create a new microservice that is associated with the same event as the welcome user function, and that's it. Then there is no need to change any orchestration logic, or there is no need to add any extra code to your platform. So that is the main advantage of the reactive architecture, coupled with the automatic key space notifications that you get from Redis when, in this case, for instance, a new record is created. And finally, like I said, the particular use case that it's really hard to implement on reactive architectures are time-based events. Things like send an email 3 days after the user is registered to your app, or remind the user that it's been 3 days since their last login, or even non-user facing notifications, such as removing a record after 2 weeks of not being accessed. That's all. That's automatic housekeeping that you can implement through these time-based events. The thing is, um, how can you implement this type of behavior? Um, you don't, without a reactive approach, you would have to do something like periodically running, potentially heavy script to check for these logical conditions, or even, I don't know, querying a database every day that could potentially have millions of records. That translates to processing power, and that also translates to resource utilization, which in the end also translates to money being wasted on days that potentially the end result is there's nothing to do, right? So instead of checking every day for something that might happen once a week, why not run your code only once a week? And that is, but how do you know when and exact moment? That is when time-based events happen. And we can achieve time-based events using Redis through key space notifications and TTL, so essentially time to live on records. By default, Redis also allows you to, whenever you create a record or update it, you can set a time to live for it. And when that timer goes out, the record will be removed automatically by Redis. If you've also enabled key space notifications, and you have a consumer waiting on that type of notification event, then you suddenly are able to react to these flags being removed. So if you have a record that's not, that is being created today, you can set a flag for it that will expire in 2 weeks. Whenever you update that record, you update the flag, and then that flag's time to live, it's reset. But if it's been 2 weeks without accessing, updating the flag, without accessing essentially the record, then that flag will expire and your record and your trigger will be sent. And then your logic can remove that record. So this is what time-based events are. And again, they're very difficult to implement from a resource consumption point of view, unless you have something like Redis here that is itself handling all the time-based logic for you. So all you care is that an event was triggered and that your logic gets executed. That is all, and that is all you need to create your reactive architecture, the message bus and time-based events. So to summarize and close this talk, on the reactive architecture side, you know that you help optimize the client's resources, both time and processing resources get optimized because you use whatever you need to use without having to spend either time or resources waiting or checking for data being available. They're easier to extend because there is no or very little orchestration logic to modify whenever you have to either add new services or change the way they interact with each other. Again, you can represent the orchestration through subscription to events. That simplifies everything, and essentially they become building blocks or Lego bricks that you can use to create different behaviors or even different platforms altogether. And Redis, on top of that, simplifies the whole thing, the whole development process, because it's already coming with a message bus out of the box for you. It provides extra events that allow you to simplify the time-based events handling. And if you're already using it, which, let's be honest, if you have big enough architecture, you probably use it to optimize other caching or whatever other, fast and uh, uh, volatile records being read and written in memory, you can already take advantage of it without affecting anything that you've done so far, and have a message bus and the key space notifications to enhance the way you interact with it. That's it. We're done. I hope that I want to thank you for watching, and I hope you got something interesting out of it, out of this talk. If you want to know more, or want to reach out to me for any related topics, just use some of the mediums there listed. Or if you found this topic interesting and you want to follow my writing medium, feel free. I write about backend, both backends and front end related topics. So you may enjoy that as well. Other than that, thank you very much again.